there were unions because they were OR problems, okay? So whenever you're looking at OR problems, you have, for OR problems, you have to think about where the two categories overlap, right? So when we were looking at things like prime number or an even number, 2 was prime and even, so you didn't count it twice. You only counted it one time. So the rule that we're going to use here, union probabilities are joined by an, OR. And the rule for OR probabilities is the probability of A plus the probability of B minus the probability of A and B. Okay. In order to be able to, and this rule works for all probabilities, whether they are mutually exclusive or not. And mutually exclusive is a new term that you may or may, I mean, you may have heard it in real life sometimes, but mutually exclusive means unable to be both true at the same time. For example, a number is even or odd. There are no numbers that are both even and odd at the same time, right? Those two categories are mutually exclusive because you're either in one or the other. You can't be in both at the same time. You are either a student at Elkin High School or you are not a student at Elkin High School. You can't be both a student at Elkin High School and not a student at Elkin High School at the same time, right? So categories that are mutually exclusive cannot be both true at the same time. Brandon Cosby is either in this classroom or not in this classroom. He cannot be both in this classroom and in the front office at the same time, right? So it's categories where those two things cannot occur at the same time. So if A and B are mutually exclusive, then the probability, you could just use the rule of the probability of A plus probability of B. And I've changed these notes since I last did them. And I don't know what's supposed to go in that last blank. It was probably important for me to put an exclamation point. That'd be a twist, wouldn't it? Maybe I meant there is no probability of A and B in this case, because if two events are mutually exclusive, like even and odd, then the probability that a number is even and odd is 0, right? So the rule for all events really still applies. It's just that if they're mutually exclusive, the probability that you have both is 0. So maybe it was A and B, but I can't remember for sure what was really supposed to be there. We'll skip it, and I'll look it up later because I don't have the most recent version of these notes printed out. Okay, so for example, you roll a pair of fair dice. So this you can refer back to that other worksheet if you still need that list, those possible combinations here. Fair means they're not tricked. Like if you wanted to have them like weighted heavy on one side, then they would always roll the same number every time. So these are fair. There's nothing wrong with them. So what is the probability that the sum of the numbers is 7 or 11. Okay, so if you look at that list, how many different probability, or how many different combinations have the sum of 7? There are 6, right? So you could do 6 out of 36. And how many combinations have a sum of 11? Only 6 and 5 and 5 and 6, right? So there's only 2 out of 36. How many of them have a sum of both 7 and 11 at the same time? None. That can't happen, right? These two things are mutually exclusive. You can't get 7 and 11 at the same time. So you could think of like subtracting a 0 here or not write it at all. So you would end up with 8 over 36, which is going to reduce to 2 over 9. Or on the test, you're going to have to probably type it in as a decimal unless I've done it as multiple choice, so 0.2 repeating for that. Just to remind us that if there was a possibility that we would have to put, like, so, if it was 7 or odd, then we'd have to subtract that probability that was 7 and odd at the same time. But in this case, it can't be 7 and 11 at the same time, so it's just 0. Okay, what is the probability that both dice either turn up the same number, meaning doubles, or that the sum of the numbers is less than 5? So what's our probability of getting doubles? 6 out of 36. And what's the probability that the sum is less than 5? That does not include 5, it's just less than 5. So 2, 3, or 4. I think it's going to be 5. 5. If you look at that, you could get 1 and 1 is the only way you can get 2. Okay, it might be 6. Okay, and so we're going to use the rule right here. So we're going to do 3 out of 6. So this is just the probability that you get a sum less than 5. But what is the probability? How many of those combinations have a sum that is a double, but also less than 5? There are 2. So we would subtract 2 out of 36. Okay, so you don't necessarily have to do it this way. You don't have to use this formula. You could do the same thing you were doing on that other worksheet first, just kind of counting them. Well, there's the 6 doubles, and here's these, but we don't need to count these again because they've already been counted. You can do that. But this rule will give you the same result. So 6 plus 6 would be 12, minus 2 is 10 out of 36, which would give us 5 out of 18 for that. 0.27 repeating. Okay. So, again, you could have done this without using the rule. So you don't necessarily have to do this. There might be situations, though, where you're going to have to use the rule. So here's another example. What is the probability that a number selected at random from the first 50 positive integers is exactly divisible by 3 or 4? Okay, so first we just got to think of, we're looking at positive integers in the first 50, so we're looking at 1 through 50. 0 is not positive, so we're not including it. Okay, so 1 through 50, if we're thinking numbers divisible by 3, we've got 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, and then 51 goes above 50, so we wouldn't include that. So that's everything divisible by 3. We're going to do the same thing for everything divisible by 4. So we would have 4, 8, 12, Okay, we got them all there. All right, so some of these are there more than once, so we'd have to cross them out. So we could do this with a formula. We could just count. Either one is fine. I don't really care which one you use. Just sometimes we're going to need a formula. So if we look at the numbers that are double, 12 is there twice, 24, 36, and 48. Okay, so those are our numbers that are divisible by both 3 and 4. So you can do it a few ways. You can just count all those numbers except for the 2 that the 4 that overlap, or if you want to use the formula, which I'm going to use just because. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers out of the 50. And then we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers out of 50 that were divisible by 4. But we would have to subtract the 4 that overlap. So you'd have 27 minus 4 would give you 23 out of 50. Is it 16? I might have counted wrong. Oh. So if it's 16, that gives us 24 out of 50, which will reduce to 12 out of 25. Okay, questions? All right, if you roll a 6-sided die twice, what is the probability that you will get at least 1 5? So you kind of got to think about what this is. When we see at least, what we're really thinking here is we get probability of 5 on the first roll, or probability of 5, wait, I don't need that P. Hold on. Probability of 5 on the second roll. It's or, it doesn't have to be both, but it could be both, right? So what we've got to do here is probability of 5 on the first roll plus the probability of 5 on the second minus the probability of 5 on both. Because we don't want to count that possibility. If we do 5 on the first roll and 5 on the second roll, there is a possibility that we got 5 on both of those rolls. So we would do the probability of 5 on the first roll, which is 1 out of 6. And then we would do the probability that we get 5 on the second roll, which is 1 out of 6. And then what's the probability that we get 5 on both? How could we get, if we get 5 on both, it's just 5 and 5 is your only possibility. Whose keys are these? These are not mine. Elkin Rec Center. Area rewards. Person. They drive a Jeep. I don't know. I don't know about this. House key. Probably. I'm thinking maybe it's from first period. It's nothing else. They'll figure it out soon, hopefully before I'm going to my room's locked up. All right, but if you think of, you're rolling the dice twice, right? We were looking at first and second rolls separately, but then at the end we're looking at the probability that they get 5 on both. So there's one way out of 36 possibilities that could happen. Okay? So if you add, Well, die is just one, but you're rolling it twice. So you can't get 5 twice on a single roll, but you're rolling it twice. So if you get 5 on the first roll, then you're done. You rolled the die. Then it's true. You rolled at least once, right? And if you get 5 on the second roll, it's true. You rolled it at least once. But there's a possibility that you rolled it 5 on the first and 5 on the second, and we don't want to count that double. So that's where we have to subtract out that possibility that it was on both. So when you're rolling something twice, you have to consider both rolls when you're talking about 5 on both. So there's 36 possibilities for rolling the dice twice, like on that page. So on the first 2, we're only thinking about each one separately, but on the last one, we have to think about the combination of the 2.
Oh, wait, so is that asking overall what it comes to the sum of 5, or is the number of 5?
Another thing you could do here, 5 at least once, look at your chart and see any of them that have at least one 5, right? And you're going to count 6 out of 36 that have one 5. You'll have, or have a 5 for the first one. You'll have 6 out of 36 that have 5 for the second one, but then you got to subtract that 1 that you counted twice there. So whenever you do this, you're going to have 6 out of 36 plus 6 out of 36 minus 1 out of 36. So that is going to give you 11 out of 36. Okay, a number 1 through 20 is selected at random. What is the probability that it will be either even or prime? So even, from 1 through 20, how many of those numbers are going to be even? 10 out of 20. So I'm just going to do 1/2. All right, what about probability that the numbers are prime? Let's list the prime numbers from 1 through 20. 1 doesn't count. You got 2, 3, 5, 7, 13, 17, 19. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of 20. But are there any we need to subtract? Are there any that are even and prime? 2. So we would subtract 1 out of 20. So we'd have 10 out of 20 plus 8 out of 20 minus 1 out of 20. So we'd end up with 17 out of 20. Okay, questions? All right, here's our next one. In a certain city has 2 daily newspapers, the Chronicle and the Times. A survey of 100 residents of the city was conducted to determine the readership of the 2 newspapers. I realize newspapers are on their way out, but this could be some other like online subscription of something. It was found that 80% took the Chronicle, 65% took the Times, and 15% took neither paper. Assuming that the survey reflects the actual readership of the city, what is the probability that a resident selected at random reads both papers? Okay, so I think these are difficult to do. They get me a little bit confused. So we want to know the probability that they read both papers. So 80% take the Chronicle, 65 take the Times, 15 don't take a paper at all. So 80, 65, and 15, what's that add up to? 80, 65, and 15, 160. So this cannot, there has to be some that take both, right? Because this cannot add up to more than 100%. So one thing that sometimes helps me for these is to think of like a Venn diagram. You guys remember doing those probably in like elementary school, maybe English sometimes. So you have over here, you've got 15 people that take nothing, right? So there's 15 there. And the Chronicle That says Chronicle right there. And times. Okay, so out of the, so you know 15 take neither. How many does that leave you with out of 100%? So if you know 15 take neither, what percentage take a paper? 85, right? So 85% get at least one paper, right? We know that 80% take the Chronicle. So what percent, 85 take at least one paper. What percent take the Times only? There's only 5 over here that take the Times only. Because it has to add up to 85 there. And there's 65 that take both, or 65 that take the Chronicle, so 60 have to go here, right? So I get 65. Okay, so we know there's 85, we're only working out of 85% because 15% don't take anything, right? And so if 80% take the Chronicle, but only 85 altogether take a paper, that leaves 5 that take Chronicle only. Okay, and then so if 60% have to take the Chronicle and the Times, then how many take just the Chronicle? What does Chronicle have to add up to? What percent take the Chronicle? 80, right? Chronicle has to add up to 80. So what percent have to take 20? Right? Because 60 is there in the overlap. Okay, so when you're doing these are confusing. These are confusing, I agree. But what you want to do first is you need to subtract out anybody that doesn't take either one, if there are any. Okay, so we start with 100%, right? But you always start with 100% no matter what you're doing. But in this particular case, there's 15% of the city that don't take either one. So they're not really included. They're over here in like a corner somewhere, right? So we're going to subtract that 15 to begin with because they're not really included, right? So we've got 85% to deal with. 85% of the people take some paper. Well, we know 80% take the Chronicle, right? So out of these 85, 80% have to take the Chronicle. That only leaves 5% left over that don't take the Chronicle. So that's where we put that 5 right over there for the Times. That 5% only takes the Times only. Then the Times has to add up to 65. So in this circle for the Times, you got to have 65. So that means 60 has to go there in the middle for the overlap so that you got 65 in that circle. It gives it to you in the problem. 65% take the Times. Okay. Then you need the Chronicle circle to add up to 80 because we know 80% take the Chronicle. 60 is already in the overlap, so you got 20 more over there, so that adds up. Okay.
I probably could do it.
You got to really slow down and think through these because I think they're confusing. It is not a simple like add and then. You got to think about the situation. Okay. The Venn diagram helps me to think about it. Okay. All right, for B. I might should have asked B first. How many read at least one of the 2 papers? That's 85%. That's really what we figured out right up here. Right? Because if they don't take a paper, there's 15%. That means the others have to take at least one, so that would be 15%. Well, I mean, 100 minus 15, which gives you the 85. Okay, questions? All right, complements. What we just did was a complement. A complement is the probability that something does not happen. So we knew there was that 85% chance, well, actually, we kind of did it the other way. We knew that there was a 15% chance they did not take the paper. So there was a 85% chance they did not take the paper, right, if you want to say it that way, that they did take the paper. So the probability of not A is 1 minus the probability of A for mutually exclusive situations where there's no possibility that you are A and also not A, right, at the same time. For example, like this might not work well if you were trying to break students down by like their race, because you have multiple students that are, you know, biracial or multiracial, so they might be, you know, white and not white at the same time, or black and not black at the same time. So this would not work well for that. But it would work well for something where you can't be both. Like you can't take a paper and not take a paper at the same time. If you could go back far enough, probably nobody is, really. So, all right, so 6. Probability that randomly, I just said this was a bad example. We might not should even do it. I forgot this was in here. Let's skip this one. It's a bad example. All right, 7. If you flip a coin 4 times, what is the probability of getting at least 1 heads? Finding the probability of getting at least 1 heads is difficult because there's a lot of combinations here. You could get, you know, you only got to get heads 1 time, right? So it could be like, you could get heads, tails, tails, tails. But it's at least 1 head. So you could get heads, tails, heads, tails. That's at least 1 head, right? Or heads, 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 heads. We could start like listing all of these out if we wanted to. Let's say order does. Yeah. Or doesn't. It doesn't really matter as much for this. Let's say order does though. So for this, what's the easiest thing to do for this is not to think about all the possibilities for getting at least 1 head. What's the opposite of getting at least 1 head whenever you're flipping tails? Not at least 1 tails. That's not the opposite, because like heads, tails, tails, tails is at least 1 head and at least 1 tails. All tails, right? The opposite of at least, the only way you can get not at least 1 head is to get all tails, right? So your probability of all tails, this would be 1/2 times 1/2 times 1/2 times 1/2. You got a 1 out of 2 chance for tails on each one. So you would get 1 out of 16. So the probability of at least 1 head is really the probability of getting not all tails, right? So rather than trying to think of all the combinations, we can do 1 minus 1 over 16. And that would be 15 over 16. So if you see one that says the probability of at least 1 of something happening, a lot of times it's more helpful to think of getting the opposite of that for that not happening. All right, so example 8, if 3 Elkin High School students are chosen at random, what is the probability that at least one of them will be female? Assume the school has equal numbers of boys and girls. Okay, so in this case, we're getting at least 1 female. So we could think of like the combinations, female, female, male, female, male, female. We could think of all that. But what's the only way this cannot occur? All male, right? And the probability of all male would be you got a 1 out of 2 chance for the first one, 1 out of 2 chance for the second one, and a 1 out of 2 chance for the third. So it'd be a 1/8 chance. So your probability of at least one female would be 1 minus 1/8, which will give you 7/8. So if you see that at least one of something, a lot of times you're going to use this complement for it. It's too hard to figure out the other way.